All right, back again. Key topic 22, SARTs. We already know SAR for SARSAT and a few of the other SAR services is search and rescue. T, we can presume, is transponders. And it certainly is. A search and rescue transponder is a self-contained waterproof transponder intended for emergency use at sea. These devices may be either a radar SART or a GPS-based AIS SART for the automatic identification system, which is kind of what the port authorities or the vessel traffic service use to identify the ships in the area. Most ships do have some sort of AIS installed, and apparently the SARTs can do the same function. The fact that they can also issue a radar signal is kind of unique, so it's like a handheld radar device. Normally when you're dealing with radar, be careful, don't aim it at your heart or anything, but this one, well, if you are in a rescue craft, this radar signal apparently is not going to be harmful to you, but just be aware that when operating around radar that there are some physical issues. The radar SART is used to locate a survival craft or a distressed vessel by creating a series of dots on the rescuing ship's radar display. A SART will only respond to a 9 gigahertz X-band, 3 centimeter wavelength radar. It will not be seen on the S-band, 10 centimeter, or other radar. That's quite a mouthful. I did put up our old radio spectrum symbols or figure, and I think we looked at this when we were talking about medium frequency distress frequencies, the 6 channels, the 2, in effect 2 megahertz, 4 megahertz, 5. And this is now in the high frequencies, kind of transition from the one in the medium frequencies. 4, 6, 8, 12, 16. I think there was one question on that. And then we got into the VHF spectrum, where we pretty much started most of our studies. 121.5 is the transponder frequency for ELTs. We saw that yesterday. Well, it's the traditional one. Back when, and it still uses a homing device, but we did see that switching over to satellite, we jumped into the next phase of UHF, and 406 is in the UHF, and that's basically how we're going to communicate with the satellites. Now we're going to jump one further from UHF into SHF, super high frequency. Now that's wave bands that are, gigahertz. All right, so we do see AIS, automatic identification system. That's also in the VHF band, but we did see that our SART can also carry that. Since we moved into the super high frequencies for radar, we do see the SART as basically the highest level of radio frequency that we send out in this aeronautical spectrum. We can get a little bit of an idea that 9 gigahertz in the X band, and up there they're basically talking about bands as opposed to the precise frequency number. I think they do both, but generally they'll say the X band because it will scan basically all the frequencies in a band. That particular band has a 3 centimeter wavelength. So think of the waves as going through the air, and 3 centimeters is a very tight wave. So, that's why radar waves could, in effect, have some physical effect on you, because the waves are coming in so compressed. only 3 centimeters apart. So it's a little more dangerous than one that's coming through 25 yards. I mean, that's barely a wave for you to see. That would be like a wave on the ocean. It will not be seen on the S band, which is 10 centimeters. So it looks like it's like an older radar because it's 3 times the width of the. It's a different type of radar that isn't as compact. So the SART will only respond to the most compact radar. So if there's a police officer that happens to be on shore and uses their radar gun that operates on the S band, they're not going to, in effect, trigger the SART. SARTs have been instrumental in rescuing several crafts and ships by reacting to the search signals sent from an X-band radar, typically 9 gigahertz. These signals are known as homing signals. Yeah, it's going to be a local signal. It's not going to be sent off to the satellite. Now, some of the SARTs are GPS compatible, but a typical radar is, pointing it at either the sky and seeing what ships are there, or for mariners, I guess it would be pointing it across the seas. In which frequency band does a search and rescue transponder operate? Is it A, 3 gigahertz, B, S band, C, 406 megahertz, or D, 9 gigahertz? All right, so they're talking about the search and rescue transponders. So they don't actually say SART. They're going to spell it out. And they want to know what frequency band it operates on. Well, we do see that primarily it is in the radar band, which is the super high frequency. So it's going to be very high in the gigahertz range, which is basically 9,000 megahertz or 3,000 megahertz. So it could be one of those. S band, we saw specifically that it does not respond to the S band. It's only, what was it, the X band? X band. It will not be seen on the S band. And 406 megahertz, that is a spot for transponders. That's for the EPIRB, but it is UHF, and it is not for the SART. SART was the highest one in our chart, and therefore it's going to be the highest one here. So 9 gigahertz. The radar SART may be triggered by any X-band radar within a range of approximately 8 nautical miles, which is the equivalent of 15 kilometers, and I think that works out to like 9 statute miles. Each radar pulse received causes the SART to transmit a response, which is swept repetitively across the complete radar frequency band. That's why they do call it a band, because the radar frequency band, the X band, not the S band, they'll broadcast on that. But it doesn't even start broadcasting until it receives a radar signal from the rescue ship or from somebody. You can see the person in the raft here, depending on what screen you've got, but holding up a SART, and it is responding to the interrogation of, it's kind of how the ELTs work. I'm sorry, ELTs, no, transponders on an aircraft. Air traffic control will send out a signal that's called an interrogation, and then the transponder on board the aircraft will reply. It'll respond with a reply. So which statement is true regarding an SART? A, this is a performance monitor attached to at least one S-band navigational radar system. There goes that S-band again. B, this is a 9 gigahertz transponder capable of being received by another vessel's S-band navigational radar system. Well, I like the 9, but I don't like the S. C, this is a performance monitor attached to at least one X-band navigational radar system. I like the X-band, but performance monitor, I'm not exactly sure. I think that's what they attach in some ships or aircraft to basically let the ground crew know what type of problems you might be having, or they're able to, on the ground, take a reading of some of the mechanical systems on the aircraft. I think that's what a performance monitor is indicating. But that's not what an SART is. That's for search and rescue. So it's probably D. This is a 9 gigahertz transponder, yes, capable of being received by a vessel's X-band navigational radar system. So yes, it's kind of poorly written. And I had to add the A just to make it sound correct. So it's going to be D, 9 gigahertz transponder, and its capability is on the X-band of the radars. Okay, nobody went for that one. When interrogated, it first sweeps rapidly 0.4 microseconds through the band before beginning a relatively slow sweep of 7.5 microseconds through the band back to the starting frequency. This process is repeated for a total of 12 complete cycles. At some point in each sweep, the radar SART frequency will match that of the interrogating radar and be within the pass band of the radar receiver. My illustrations, I don't know. I see a SART sending out a signal. Apparently, it could go 5 or 6 miles to the rescue ship, but an aircraft can receive it, or a helicopter, at least here, up to 50 miles. And it is a homing signal. Hopefully, you had something that guided them that there was an emergency anyway in the vicinity. So once they're in the area, they want to pinpoint your actual location. And a SART, which is usually attached to the rescue or the survival craft, is equipped to do that. It's a little more complicated. That's probably why they waited till nearly the end of the element to cover it. Question is, at what point does a SART begin transmitting? A, it immediately begins radiating when placed in the on position. Then I have thought I had something here. All right, I guess I thought I put something to show the on position here, or the armed position. It's not there. All right. Well, it's not on. And it doesn't automatically start radiating once you turn it on. B, it must be manually activated. Do you have to actually turn it on when you think somebody might be in the area? Or C, if it has been placed in the on position, it will respond when it has been interrogated by a 9 gigahertz radar signal. So I guess it is the on position. You turn it on, and then it basically sits there until a ship sends out a radar signal. Then all of a sudden it jumps up and it's excited to be interrogated, and it responds quickly. D, if it has been placed in the on position, it will begin transmitting immediately upon detecting that it is in water. And no, the SART does not do that. You don't really put it in the water. I think they're referring to maybe the EPIRB, which many of them are activated, or they'll start sending out a signal upon immersion. So I guess I like C. When it's switched on, it will not begin transmitting until it receives a signal, and that prolongs the battery life. Wonderful. Nobody went for that one either. All right, I think I lost you. A SART also has an audio or visual indication of its correct operation. And
I mean, I didn't even see the prompt for the poll come up.
Oh,
So
okay. Let's see. Maybe I'll end it and then relaunch it on this one here. The SART also has an audio or visual indication of its correct operation and informs survivors when interrogated by the radar. An audible beep is heard every 12 seconds when there are no radars in sight, and every 2 seconds when interrogated by radar. So I guess you can get excited and start waving your arms. The bright color of SARTs enables their quick detection, whereas a combination of transmitter and receiver enables it to transmit as well as to receive radio signals, or I guess more appropriately, radar signals. So it receives and transmits. What is the purpose of the SART's audible tone alarm? A, it informs survivors that assistance may be nearby. B, it informs survivors when the battery's charge condition is weakened. C, it informs survivors when the SART switches to the standby mode. Or D, it informs survivors that a nearby vessel is signaling on DSC. So you're hearing an audible tone. Beep. What does that mean? The battery's low? Hope not. Yes, it tells them that assistance may be nearby. I suppose since you paid a good amount of money for this SART, you're going to want some sort of assurance that it did work. Yes. If the radar SART is within range, the frequency match during each of the 12 slow sweeps will produce a response on the radar display. Thus, the line of 12 dots equally spaced by about a half a nautical mile will be shown. So it looks pretty clear on the radar screen. How should a signal from a search and rescue radio transponder appear on the radar display? Is it a series of dashes? Or B, a series of spirals, all originating from the range and bearing of the SART? C, a series of 12 evenly spaced dots? Or D, a series of 20 dashes? Well, we know it's dots, so it's not a dash or a spiral, so I guess we're just only have the one option, C. And that is correct. They will align with the source location, so it's like a little arrow that's pointing them to the way. A SART is carried in the life raft when abandoning a ship in distress situation. It should be deployed at a height of at least 1 meter above sea level and switched on immediately to its standby mode. I thought I saw the standby mode. I guess standby or on or... This will allow the SART to respond to transmissions from a vessel's, helicopter's, plane's X-band radar and SAR operations. All right, so I did try to find a close-up of the actual switch, and because we don't have a SART, maybe that's over in Marine. They might have one on the shelf somewhere. I might have to go over there. But I guess this one says standby, so it certainly know how to operate it. How can a SART's effective range be maximized? How do you actually get it to broadcast as far as possible? A, the SART should be placed in water immediately upon activation. Oh, so let's turn it on and throw it overboard. B, the SART should be held as high as possible. C, switch the SART into the high power position. D, if possible, the SART should be mounted horizontally so that its signal matches that of the searching radar signal. All right, so is this guy putting it in the water, or is he holding it as high as possible? Or is he holding it horizontally, like trying to point it at the horizon? And we don't know anything about this high power position, so that's not necessarily you don't really adjust the power on the SART. It's not an adjustable. You're probably going to want it on high, but it's going to save the battery until it's interrogated anyway. But I don't believe there's a high button. So it's basically B. Hold it as high as possible. Held up in the vertical plane and as high as possible when activated. Yeah, that's your job on the life raft, to hold that SART up as high as possible. Doesn't seem like a fun job, but if it's effective, it's an invaluable job. All right, that ends that one.